So in this problem we have a toroid, and if we want to find the magnetic field inside the toroid, well, we draw an Amperian loop here and we integrate the magnetic field around this loop, and that's equal to mu naught times the enclosed current, which is the number of turns times the current. So the integral is given by this, and we can then find the magnetic field inside the toroid, which depends on the distance from the center. So if we want to find the flux of magnetic field inside the toroid, well, let's look at the toroid cross-section. So we want to find the flux through this area. The flux through that area, let's say we wrap some wire around here. We want to find that we wrap a wire with n prime turns. The flux through this area, which is dimensions b and a, and this distance is r. Then we integrate from r to r plus b the magnetic field times dA, and the magnetic field inside the toroid is what we already found it to be. And dA is just a times dr, where a times dr is dA. So we can do this integral, and this integral is given by this. And now that we have the flux through one of these areas, we multiply it by n prime because there's n prime terms in the wire that we wrap around. So this is the total flux through the wire we wrapped around the toroid with n prime turns. Okay, so if we want to find the induced EMF in that wire that we wrapped around the toroid with n prime turns, then we take the derivative of the flux and we get the EMF. So we take the derivative of this. Everything is constant except the current, so we just take the derivative of the current with respect to time. And the current is given by this expression, so the derivative of that is this. So we put this into di dt, and now we have the EMF that's induced in the wire we wrap around the toroid. So we have the EMF in that wire, or the magnitude of that EMF is equal to this. Okay, where we plug in the derivative of the current at the end. So if we plug in the numbers for all of these things that we are given in the problem, we know what n prime is, we know what r is, what b is, what omega is, and so forth. We can plug all of this in and multiply it by cosine of omega t. So this whole thing, once we multiply it out, just gives us this number. So that's the total flux, the total induced EMF in the wire.